So today we're going to talk about a square, a rhombus, and a trapezoid. And I have a handout to give you when we get done talking about this. All right. So a geometric figure is a rhombus. That's how you say that word, rhombus. So your first blank there should be rhombus. A geometric figure is a rhombus. If and only if it is a quadrilateral with 4 congruent sides. What else do you know has 4 congruent sides? Where all 4 sides are the same. In a rectangle, are all 4 sides exactly the same? A square, right? So a rhombus and a square are going to be very similar to each other, and we'll talk about some of their differences in just a minute. So if ABCD is a rhombus, the plural form of rhombus is rhombi, in case you wanted to know. Those of you that are Scrabble players, you can now put a new word into your vocabulary, rhombi. Okay? If ABCD is a rhombi, then it has 4 congruent sides. I like to think of a rhombus as a slanted square. So we know that a square has all 4 sides, but a rhombus is kind of a slanted square. Okay? All of these things right here are all properties of a parallelogram. Okay, so all these things are properties of a parallelogram. So a rhombus has all of the properties of a parallelogram. So that means opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. So all of these properties are also true for a rhombus. Okay, so in addition to a rhombus, okay, let's draw our picture here. So we know that all 4 sides are the same. So let's draw that. We know all 4 sides are congruent. Okay, we know that we have 2 diagonals, so let's draw 2 diagonals from A to C and B to D. The diagonals bisect each other, right? So they bisect each other, which means that this is congruent to this one. And this one is congruent to this one. But they're not the same. Okay, so the diagonals are not congruent. They just bisect each other. I also, in my triangle, do you see that I have created 2 isosceles triangles? Don't mark this, but look. This big triangle is an isosceles triangle, right? Conversely, the other side is also an isosceles triangle. Do you see that? Okay, so you have 2 isosceles triangles. Okay, each diagonal bisects a pair of opposite angles. So this is new for us. In a rhombus, this angle is the same as this angle. Okay, up there at A, those 2 angles are the same. And so are these down here by C. All 4 of those angles are going to be exactly the same measurement. Because if I tell you, okay, that if this was 80 and this is 80, right? Because opposite angles are congruent. If I were to cut this down the middle, how much are each of these on the side? They're each 40, right? I could say that this one is 40 and this one is 40. But if I cut this one down here also in half, then this is 40 and this is 40. So do you see how all 4 of them are exactly the same? Okay? So it's also going to be true about angle B and angle D. Okay, so this angle right here is congruent to this one on this side. And they're congruent to the ones that are across from them also. Okay, another thing that we are learning that's new about a rhombus is that the diagonals are perpendicular to each other. And what does perpendicular create? A right angle. So that means in here in the middle you have 4 right angles. Each one of those is a right angle because the diagonals are perpendicular to each other. Okay, so let's fill in our blanks here. Says each diagonal forms 2 congruent isosceles triangles. Each diagonal forms 2 congruent isosceles. Oh man, sorry. Isosceles triangles. We said that each diagonal bisects a pair of opposite angles. What did we say about the diagonals? They are what to each other? Perpendicular to each other, so we're just going to draw our perpendicular symbol. And remember, if they're perpendicular, they make right angles. That's really important to remember. That's one of the forgotten things about rhombi. They make right angles. And both of the diagonals form 4 congruent right triangles. All right, so if I ask you, is this a rhombus? You have to prove one of these 3 things. Remember, we've done this so far with parallelograms and rectangles. So you just need to choose one to prove. You don't have to show all 3, you just have to choose one of these. So if a quadrilateral has 4 congruent sides, it is a rhombus. Okay, so if you prove that all 4 sides are congruent, then it's a rhombus. How do you prove congruency? What formula do we use for congruency? You guys remember? Come on, don't fail me now. Distance, thank you, Tish. So if we're checking to see if all 4 sides are the same, then I'm doing the distance formula 4 times. Okay, if a quadrilateral has perpendicular diagonals, then it's a rhombus. And how many diagonals do we have in our rhombus? How many diagonals are there? 2. And how do we prove perpendicular? What formula do we use to prove perpendicular? Good, slope. So if we need to use the slope formula and we have 2 diagonals, what are we going to do? Good, the slope formula twice. And lastly, if I prove that the diagonal bisect a pair of opposite my pen is running out. Opposite angles. That's terrible handwriting. If a perpendicular has diagonals that bisect a pair of opposite angles, that's what that says there, then it is a rhombus. Do we do a formula for angles, though? We don't. We just have to find the measurements of them, okay? So if we're talking about angles, we don't have to use distance or slope or midpoint or anything. We just need to figure out if the angle measurements are congruent or not. Okay, so let's do a couple examples. Let's turn our paper over. Okay, it says ABCD is a rhombus. So I know that this is a rhombus. So let's go ahead and mark some things that we know before we even read the question. If this is a rhombus, I know that all four sides are the same. Okay, and I could continue to mark the diagram up if I needed to, but let's look at example 1. It says ABD is 60. ABD is 60. So that means this angle in here, ABD, is 60. Find BDC. So I want to find this angle down here. Well, remember we talked about in a rhombus, this angle is the same as this angle, which is the same as this angle, which is the same as this angle. So how much is the measure of angle BDC? Also 60 degrees. Okay? So the measure of angle BDC is 60 degrees. Okay? Next question says, if AE is 8, find AC. So I need to find this whole thing. Well, in a rhombus, what do we know about the diagonals? The diagonals themselves, AC is not the same as BD, right? The diagonals are not the same, but the diagonals do what to each other? They bisect each other. They cut them in half. So if AE is 8, how much is EC? 8. Right? So if I add 8 plus 8, I should get 16. So you could show your work saying 8 times 2 is 16. So AC equals 16. Okay. Number 3 says AB is 26. So let's label our diagram. AB is 26. BD is 20. So this whole thing out here is 20. Find AE. This is a great question. This is in fact a test question. So I would star number 3 in your notes. Make yourself a note somewhere that this is a test question. This question will be on your next test. In case you were looking for questions that are going to be on your test, you should look at number 3. All right. If AB is 26 and BD is 20, how am I going to find AE? Because you haven't really been thinking this way, I'm going to help you out a little bit. If B to D is 20, how long is BE? 10. Okay, so we're going to mark that as 10 instead. And I'm going to do this. I'm going to draw a separate diagram over here so that we can see what we're doing. So I know that this is 26, and I know that this is 10. And I'm trying to figure out how much this section is. Okay, I have a triangle. What do I know about in the middle, though? Any ideas in the middle? What do we know about the angles in the middle? They're right angles, right? I have created a right triangle here. If I've created a right triangle, and I know 2 sides of the triangle, how do we find the third side?
C squared equals A squared.
Okay, Elena is reminding us about the Pythagorean Theorem. The Pythagorean Theorem, which was on your test yesterday, says if you know two sides, you can find the third side. What value is always C, Vanessa? C is always the what? Hypotenuse, okay? So, Nick, which one is my hypotenuse in this example? 26. So I'm putting 26 in for my C value. And then I have 10 squared plus x squared. All right, take a minute. You have a calculator. If you don't, you should get one. What are we getting when we take the square root of 576?
24.
Amanda says 24. Does anybody agree with 24? 1, 2, 3. Okay. So x is 24. Now let's go back and read what our question said. It said find AE. And indeed, AE is just this part right here. So my final answer would say AE is 24. On your test, if you do not use the Pythagorean theorem in a question where it has a diagram like this and multiple questions about it, you've done something wrong. You need to use the Pythagorean theorem to help you find these measurements, okay? So, any questions on number 3? On number 4, it says find the measure of angle CEB. So if I go back to my diagram, angle CEB is here. How much is this angle right here? What do we talk about? All the middle angles. They're 90 degrees. There's nothing more I need to do here. I just know that the measure of angle CEB is 90. And the reason I know that is because my rule says if it's a rhombus, you got right angles in there. All right, number 5 says if the measure of angle CBD is 58, find ACB. So I want you to label your diagram with this information. CBD is 58. So we have 58 up here. Find ACB. They want me to find out how much this one is. Any ideas? We only know 2 angles, and I have it, or we only know 1, right? I'm looking at this triangle. Mackenzie, I see you working. What are you thinking? Share your knowledge with the rest of the class.
58 plus 90.
Okay, where'd you get 90 from? Good. Mackenzie's remembering that this is a right angle right here. So we have 58 plus 90 plus what?
That's 148.
Okay, so we have this x over here. All right, so let me transfer what you're saying. 58 plus 90 plus x equals 180. Okay, because we have a triangle and all 3 angles in a triangle add up to be 180 degrees. Patrick, what'd you get for x? Where's your calculator? Okay, I'm coming back to you on the next one. Be ready. Tish, what'd you say? 32. Now, they didn't ask me to find x. They asked me to find Measure of angle ACB. All right, so I need to make sure in my answer I say the measure of angle ACB equals 32. Okay. Questions on that one? You have to remember that that middle angle is 90 degrees every time. All right. Okay. Excuse me. Thank you. All right, if AE is 3x minus 1. Okay, so if AE is 3x minus 1. And AC is 16. There are two ways we can do this. That's a 16. Can you see that? There are two ways you can do this. Are we going to set 3x minus 1 equal to 16? Did you say yeah? No. Okay, if I set 3x minus 1 equal to 16, I'm saying that this small piece right here is equal to the whole thing. Does it make sense that this little piece right here equals the whole thing? That doesn't make sense. Okay? But I know that the whole thing is 16, so how much are each of these small pieces? They're each 8. So you could say 3x minus 1 equals 8. What's another way you could say this? Any ideas?
I did 2 times 3x minus 1.
Okay, so Elena's saying that this is also 3x minus 1, so she's adding 3x minus 1 plus 3x minus 1 equals 16, which is also the same. 2 times 3x minus 1, wow, equals 16. Okay, either one of these will work. Okay, so Patrick, I told you I'm coming back to you. I need an answer for x. I would start right here, this one. 3x minus 1 equals 8. What'd you get for x? 3. Anybody else get 3 for x? Excellent. Thank you, Austin. Okay. All right, any questions about a rhombus so far?
Minus
X.
1 equals 3.
Yep.
How will you go back to 16? It's now 3x minus 1 plus 8 equals 16.
You could do that as well. That would work as well, yes. Did you still get x to be 3? Yeah? Okay, let's talk about a square now. So a geometric figure is a square. There's your blank right there. A geometric figure is a square if it is both a rectangle and a rhombus. So a square has all of the properties of a rectangle and all of the properties of a rhombus. That's a lot to keep track of. Okay? It has all of these things. Opposite sides are the same. All 4 sides are the same. You got 90-degree angles in there. But let's talk about this. If I look down at this diagram down here, I know from the property of a rhombus that this is a right angle, right? You don't need to mark this yet. But this is a right angle. And if this is a right angle, remember I said that if it's a square, okay, then I know that these two are the same, exactly the same, because the property of a rectangle says that your diagonals are all the same. If these two are the same, don't I know that these angles are the same? Would you guys agree with that? And if I've already used up 90, how much is left for each of those if they have to be the same? 45. So a square is going to be a 45, 45, 90 all the way around. 45, 45, 90 all the way around. Every triangle in a square is going to be that way. Okay? So a square is a regular. We use this word regular. quadrilateral because all the sides are congruent and all your angles are congruent. All the sides are congruent and all the angles are congruent. A square is, everything is perfect in a square, if you want to think of it that way. All right, so why don't you see if you can do 1 through 5? Why don't you see if you can do 1 through 5, and then we'll come back together. Label your diagram each time. All right. Let's see how far you got. Number 1, if MA is 8, how much is AT, Austin?
8.
Also 8. Excellent, because all the sides are the same. Okay, if the measure of angle HST is here, HST. Adela, how much is that angle? 90 degrees. Excellent. Okay, next one is angle MAT. Tracy, how much is angle MAT? 90. Is that a question or a confident answer? Somewhat confident. It should be a really confident answer. MAT is also 90 because remember, a square has all the properties of a rectangle, and a rectangle has all 4 corners are right angles. Okay, so this is also 90. Excellent. If HS is 2, then HA is how much, Amanda?
4.
4. Excellent. And MT is how much? Mackenzie? Also 4, because the diagonals are the same. Okay. And the measure of angle HMT, Elena? 45. Measure of angle HMT. HMT is here. Remember I told you that all the corner angles are 45. Excellent. Any questions about a trapezoid? I'm sorry. Wow, that's next. A square. Okay, let me show you this example of a handout for you. We've talked about a square, a rhombus, a rectangle, and a parallelogram. So now we're going to finish up a quadrilateral with a trapezoid. Because remember, quadrilateral just means you have 4 sides. So we have this thing called a trapezoid. So a geometric figure is a trapezoid. If and only if it is a quadrilateral with exactly 1 pair, this is really important, of opposite sides that are parallel. It only has 1 pair of sides that are parallel. What that means is you would agree if I were to extend these lines AC and BC, eventually they would cross, right? So these two are not going to be parallel because eventually they would cross. So my 1 parallel sides would be side AB side AB is parallel to side CD. These are called the bases. So the sides that are the same are called the bases. The sides that are parallel are called the bases. Okay, and so the non-parallel sides would be AC and BD. These sides are called legs. Oh my goodness. So then we have some base angles. So if I look at the bottom one where C and D are, I can say that C and D are base angles. So I know that angle C and angle D are base angle pairs. What might be another base angle pair? Angle A and angle B. Now, I accidentally drew them congruent, but they are not necessarily congruent. Okay, so then another pair would be angle A and angle B. Then we have what are called leg and base angle pairs. So leg and base angle pairs would be angle B and angle D. This is an and symbol. And angle A and angle C. Leg and base angle pairs are supplementary. So if you were to add angle B plus angle D, you would get 180. If you added angle A and angle C, you would get 180. That is not true if you add A and B or C and D. Okay, so base angle pairs are not supplementary, just leg and base. All right? So you can go between here and here. These are 180, or these are 180, but not across. Are we okay with that? Not across. Those are not 180 together. All right, we say that a trapezoid is an isosceles. That's your blank there. An isosceles trapezoid if the legs are congruent. Oops. Okay, so if I look at my trapezoid and I know that the legs are congruent, then it is an isosceles trapezoid. So there are some properties, and we're going to be dealing most of the time with isosceles trapezoids, not just regular ones. We're going to deal mostly with isosceles ones. So we have our picture here of trapezoid URFT. Both pairs of base angles now we need to understand. Let's think about back to our triangle. If we had an isosceles triangle, what do we know about base angles? They're congruent. Okay, so now the rule is still kind of the same. If the isosceles, or if the trapezoid is isosceles, then those base angles are congruent. So in this example, if you know that they are congruent, if you know your legs are congruent, then the base angles are going to be congruent. Also in an isosceles trapezoid, the diagonals are congruent to each other. Those are the same length. Does it look like the diagonals bisect each other? Does this piece look the same as this piece? They don't look the same, and they are not the same, okay? So they don't bisect each other. But as a whole, this whole diagonal and this whole diagonal from R to T and U to S are the exact same, okay? Opposite angles are supplementary. Opposite angles are supplementary. Let's look at what that looks like. Would you agree that this angle is pretty small, right? This angle right here is pretty small. And if I were to flip my paper upside down, I would see that this is pretty large, this angle. So they can't be congruent, right? That doesn't make sense that they look exact. They're not exactly the same. So they are supplementary though. And both diagonals form one pair of congruent vertical triangles. So that would be this triangle and this triangle are exactly the same, right? Because we got vertical angles here. Okay, we know that those two triangles are the same. Okay, a segment of a trapezoid is called a mid-segment. Is called a mid-segment. If and only if it connects the midpoints of the legs. So we had this with a triangle. Do you guys remember with our triangle we said we had this mid-segment here, right? If it connected the midpoints. Do you guys remember doing that? Please say yes. Yes. Okay, and so, I'm sorry, instead of mid-segment, the more official definition is median. So let's write median instead. I'm sorry. It means the same thing. A segment is a median. I'm sorry. If it goes through the midpoints. So if I draw a trapezoid that has a median, so let's draw a trapezoid. Let's draw a median. If it is a median, then it is parallel to the bases. Right, that makes sense. They all have the same slope. They're all going the same direction. They never will intersect, all three of them. And the measure is half the sum of the measure of the bases. Whoa, what does that mean? Well, if we take base 1 plus base 2 divided by 2, that's going to give us our median. Base 1 plus base 2 divided by 2 gives us our median. And so back on this diagram, base 1 and base 2. It doesn't matter which one is 1 and which one is 2. Okay, but the top and the bottom. Excuse me, the bases. Okay, so the first thing we're going to do in an example is to prove that this is a trapezoid. If this is a trapezoid, what does that mean? How do I know it's a trapezoid? One pair of sides is what? Come on, guys. Thank you. One pair of sides is parallel. So if you know that one pair of sides is parallel, then we need to check the slopes. But the first thing I should do on this is to graph it. So I want you to graph this diagram. Okay, so we've been doing the same thing over and over. Graph these points, please. Okay, once we have it graphed, we need to check the slopes of all four sides, and I only want one pair of sides to be the same. All right, so we're going to do 4 slope checks. So let's check the slope first, the slope of AB. Put your y's on top. So I'm getting our slope to be 0 for AB. So I know that this one is 0. Okay, so let's find the slope of which one should be parallel to AB. If AB is going to be a base, which it kind of looks like it, which one should be parallel to AB? CD. So let's check that one, or DC, whichever. Let's check that one next. So let's do the slope of CD next. You're getting 0 as well? Okay, so great. That means that AB is parallel to CD. So I know that I have at least one pair of sides that are parallel. Do I want BC and AD to be parallel? No, because if it's a trapezoid, only one pair can be parallel. So I need to verify that BC and AD are not parallel. So I need to find the slopes of BC and the slope of AD to make sure they are not the same. Okay? Do it. You can do slope formula. Did you get -1 for the slope of AD? Yeah. Yes? Okay, and the slope of BC? (3 over -1) to make -3. So these slopes are not the same. So they are not parallel. All right, so is this a trapezoid? All right, so I would say ABCD is a trapezoid. Then they asked me to prove if it's an isosceles trapezoid. How would I know if this is an isosceles trapezoid? Because I've already established that AB and CD are my bases. So if I want to prove that this is a trapezoid and it's isosceles, what do I have to check? What do I need to know about BC and AD? I need to know the distance, right? So I need to know if they're congruent. We're not going to do that for the sake of time. Make yourself a note, though. For isosceles, that means that BC must be congruent to AD. And then you would do the distance formula 2 times. Okay, so if we were going to check to see if this was isosceles, those two must be congruent, so you're going to check the distance formula twice. Okay? All right, so number 2. All right, now we're dealing with an isosceles trapezoid. We know that, we don't know that it's isosceles, but we do know that MN is the median. Okay, and remember we said that the median is the midpoint of the two sides. Okay, so let's find MN if HJ is 32 and LK is 60. So remember our formula from the other side. Base 1 plus base 2 divided by 2 gives you the median. So they're asking me to find the median in this one. So you would set up 32 plus 60 divided by 2. So 92 divided by 2 is what? 46. So the measure of MN is 46. Okay, find LK. So they want me to find this down here. If MN is 28 and HJ is 18. So MN is 28. Now this time they gave me the median, right? And I don't know one of the bases. So I'm going to put an X in for my LK. And then let's look at our formula here. Remember, I know that this is the median. So if I know how much the median is, which is 28, right? I can say 28 equals X plus 18, so those are my two bases, divided by 2. Now we get into some algebra. X plus 18, so I added my two bases and divided by 2 because that's what the formula says, and equal it to my median. Nick, what do we need to do to solve this problem? Okay, Victoria, is that what you said too? Good. Excellent. Okay, so multiply each side by 2. Go ahead and do that. And solve for X. Now he will be. Oh, I'm almost done. You just use 2 more.
And we're getting swivel next week. Okay.
They swivel?
Eric,
Oh.
Eric Stewart's having a trace.
Oh, perfect.
So we can get that going. We're
Okay.
gonna have it for a couple months. He's got 2 of them.
Okay, perfect. Okay.
10 minutes are done.
Okay. And X is how much? X is how much? 88?
38.
Oh, wow. Okay, 38. So they didn't ask me to find X, they asked me to find LK, so I need to say LK equals 38. Almost done, almost done. It says find angle LMN if LHJ is 1/16. This is an interesting question. I know, you don't really care. But, okay, so LMN is this angle here. Right here. Can you see my little blue mark? LMN is here. And if LHJ is 1/16, Remember we talked about these are parallel, right? These two lines are parallel. What kind of angles are these two? If we talk about parallel lines. Thank you. Corresponding, right? I have this one and this one. Do you guys see that? And what do you know about corresponding angles? They are what? Congruent. Okay, so if I know that that LHJ is 1/16, then that means that the measure of angle LMN is also 1/16. Excellent. All right, last question. Find the measure of angle JKL. Find JKL, this angle down here. If this is an isosceles trapezoid and HLK is 62. Okay, so these are both base angles. Would you agree with that? L and K are base angles. And what do you know about base angles in an isosceles trapezoid? Look back at your notes. Base angles are what in an isosceles trapezoid? They are congruent. So if HLK is 62, how much is JKL? Also 62. So the measure of angle JKL is 62. All right, go take a break. Be back at 10:50, please.